All right. Welcome, everybody. We're back here again to discuss math for med stuff. So welcome on in. A couple things to talk about. So the new modules are up. So chapters 12, 13, and 14. And then your discussion that you'll wrap up on chapter 14. And the new homework assignments are up. So chapters 12, 13, and 14 are up. You can't see 14 because it just ran out of room. If I click more here, you'll see the 12, 13, and 14 are all in there. So you'll see those when you go into your homework. You'll see they're available and you can go through them. These ones, especially chapter 13, is long. It's long. These are some of the most important chapters in the book, is that you're able to make these kind of conversions that we're doing. And so it's just a chance to get more experience with it and more practice, so that way you'll be that much better when you're doing it in the real world. Okay, so please do take these assignments seriously. It seems like most of you are doing that, so that's good. Just take it seriously, because it's sort of people's lives in the balance. And it's math, and it's units. The number one thing that's going to guide us through these three chapters we're looking at today is the units. If you track the units, am I talking about milliliters right now? Am I talking about milligrams? What am I trying to get to? So the unit that you have versus the unit that you're trying to turn things into, the whole thing is guided by units. Okay, and a lot of times we see this. The science teachers complain about it. We have a hard time with it in our math classes. Students try to not use units. They just want to get rid of it. So instead of saying 45 miles per hour, it's just 45. That isn't going to work. That is basically a recipe for setting yourself up to make mistakes. The whole thing that makes it easy to go through these, once you get the hang of it, I'm not saying it's going to be easy out of the gate, but once you get the hang of it, these problems are pretty easy because they're more or less straightforward. But the whole thing that takes you through the problem is tracking the units. So don't be lazy. This is one of those situations where, it's go slow to go fast. If you take your time and you set up the problems properly, you're just going to sail right through them. If you're trying to skip steps, like not writing the units out and not lining up your units for the conversions to cancel correctly, you're just never going to get to the end. So do be aware of that, right? And the chapter 12 is a little bit longer of a homework assignment, but like I say, it's a calculation and a conversion that you'll be doing fairly regularly, I think. And so you want to be comfortable with it. You want to be good at it. So we're going to go through a few of these different calculations today, look at the different things, and then you'll be able to do them on the homework. And you can see the new modules are up. Only one of them has a video, and it's actually a video that got posted in the earlier chapters as well. But I'm posting it again because, like I say, I think this is one of the more important pieces. You're gonna need to be good at it. So keep that in mind. The other ones don't have a specific video, but I'm going to go through and give you, I'm going to show you some examples today. In fact, you won't be able to see them on Zoom, but you will be able to see them on the YouTube stream. And then later, if you need to go back and watch them again, they'll be in the video, so you can come back and watch these if you need to. But I'm going to walk you through some examples on how to do this, so that you have exactly what you need to get through them. Let's see, where am I? Was there anything else I wanted to say before we get started? We've got that. Oh, I know what I wanted to say about homework and homework being due, right? Anytime, I don't know, students just have a lot of opinions about when homework is due, whether, for lots of different reasons. So the thing is, remember when we first set this up, which was only a couple weeks ago, where we moved to the new book with the new homework, I gave you extra time on the homework because I knew people, some people were going to need a few extra days to get the homework set up. So, and I guess I don't always understand this. I'll have students come to me and they talk about like, oh, I assumed the homework was going to be due on this day. Don't ever assume the homework's going to be due at a certain day or time. Look at when the homework is due. Okay, I don't quite understand that line of reasoning. When it's on the homework, it says when it's due, so then you can look and you can know exactly when it's due. So that is basically on the homework assignments, you're getting a little less time than you did for the earliest chapters, but that's because I was giving you time to get the, for those of you who had some trouble getting the homework set up, you weren't going to then be facing late penalties. But we're getting pretty near the end of the semester, and the semester is what I think we're now a month from now puts us like at the end of finals or something like that, or maybe even after finals. So, we're getting close to the end. So I can't give you a ton of time for all these chapters. And if I can't have a ton of it due at the end because students will put it off, try to do it at the end and then not do a very good job. So make sure you're watching the due dates that are in the homework. It'll tell you when the homework is due. Watch that. Don't make assumptions about, oh, well, I thought we had an extra week to do it. Don't do that. Just look. I mean, it makes sense. It's right there. So just take a look at that, and then make sure you got these done by April 24th. You want to have the discussion done. You got these chapters done. You got the homeworks in here to get wrapped up, and then we're moving forward from there. Okay, I think that's everything. Is there any questions or concerns that anyone wanted to bring up? I'll take roll in a couple minutes, maybe between chapters 12 and 13. Maybe I'll remember to take roll then. So we'll do that in a bit. Like I say, you're welcome to hang out in Zoom, but you're not going to see the visuals as well, so you might want to jump on the YouTube stream if you're watching. We only have like 5 people on the YouTube stream, but you're going to want to see this because you're going to, like I say, the calculations we're doing are not difficult. We're talking about multiplications and divisions. That's all we're doing, and, like for the homework and stuff, if you need a calculator, go for it. But you do need to know how to apply these things. So you want to make sure you're seeing how that's done. Okay, so we are in chapter 12, ratio and proportion. So basically what we're looking at today, I've kind of got it set up so the rest of the semester, the homeworks are in groupings that are the units in the book. So like this time we're doing the 3 chapters that the book calls Unit 4. Next time we'll do Unit 5, then Unit 6, then Unit 7, and then we're done. Okay, so that's kind of how we're going to go. And I know that might seem weird because we've got Section 5 only has 2 chapters and Section 6 has 5 chapters. But they kind of go together as a cohesive unit. So it just kind of makes sense. If you're working on one concept at a time, the homework's going to flow a little bit better. So that's why it's set up that way. It just makes it a little easier to keep track of what's what. So we're looking at chapter 12, and this is going, basically what we're looking at today is conversions. So let's say that you have to give a dose in one kind of unit, but the information you have is in another kind of unit. So maybe whatever you're getting the drug from, whether that's a tablet form or you're going to be setting up a syringe calculation like we talked about last time, maybe the information on the bottle is given, or the container or whatever, is given in one type of units, but what you were ordered to give is in a different type of units. So that's confusing. It'd be like a similar situation would be if you go to Europe and you're driving around and you're used to judging speed in miles per hour, but the car that you're driving in is in kilometers per hour. That's a different unit than you're used to. So you're going to have to get your brain to think about kilometers per an hour so that you're driving safely over in Europe, and the same vice versa. If someone comes to the United States, they're probably not used to miles, this silly, ridiculous distance that we use here of a mile. People in Europe aren't going to know what a mile is. So you have to change your way of thinking, or you have to change your units so that you actually understand what that unit means, and then you can judge it accordingly. So that's what we're looking at today, is different types of, how do we do these? Basically, we have 3 different kinds, 3 different unit conversions to get to from one type of unit for these dosages to another. And then obviously it's really important that we keep the same amount, right? Like there's a conversion between miles per hour and kilometers per hour. Someone's in Europe driving a car at some kilometers per hour, You can match that speed in America, even though someone's driving at miles per hour. They can be going the same speed, but their readings are going to be different from each other because one's in miles per hour and one's in kilometers per hour. But obviously for dosages, you want to make sure that those two different amounts, even though they use different units, are really the same amount of medicine that you can keep track of. So basically, we've got ratios that you're going to be looking at, and then we're going to be using the ratios to set up proportions, which is basically where you have a ratio with an equation in it, and you have to go through and solve that. Now, the book gives you two different ways to do this, and I'm going to recommend that you use one over the other, although technically you can use either one, but I think one of them is more error-prone and just not as convenient for a number of reasons. Okay, so let me double check if I said everything. Yeah, right. Okay. So there are two different ways to express a ratio. The numbers can be written as a common fraction or separated by a colon. Okay, so a lot of times, like if you go to, there are certain scenarios where you might see it written this way. Sometimes in books, especially if it's non-mathematical books, they like to give ratios this way. 50 milligrams per 1 milliliter. That's fine. Like that's a fine way of writing things, and you can communicate that information, and that's fine. But I would say in general, you want to default to the common fraction way of doing things, okay? One reason that you see this a lot more on containers is that you can just see it fits a little better, right? You see how it fits on a line? So you don't have this weird thing you get in math books where all of a sudden you have all this space because we're sometimes using fractions and sometimes not using fractions. So a lot of times when things are on like the printed world where it's on a bottle or in a book or something like that, they choose the version that has the that's going to fit the best, right? Like on these labels, they're trying to get everything so small and compact, so they're really concerned about like fitting. But when it comes to calculations, you're probably better off using fractions, right? Especially since that won't be a problem. If you have to write on a piece of scratch paper to do a conversion, you're probably not worried about space. But the nice thing about writing them as a common fraction is that you're familiar with common fractions, right? We have a whole system that you've been learning when you took your algebra classes about how to manipulate fractions. And I get that some of you are a little nervous about fractions, but you just kind of have to get over it. You're going to be dealing with fractions and decimals and all that kind of stuff every day, right, in your career. So it's much better to just get over that fear and that nervousness about fractions and get really good at them, and then you'll just be really good, right? You'll be really good at what you do because you won't have that one thing that's kind of like, I'm still kind of weak on fractions. Just get good at them, and then, you'll be confident about it, and you'll make less mistakes, and then you'll know what you're doing. So when it comes to fractions, we know how to operate on these things. We know how to do multiplications. We know how to do divisions. We will see today, using multiplication and divisions, how to use our conversions. So it makes it a lot easier. So they give you the option in the book that to write it either way. But what I will say is I think that using the colon convention is more error prone just because you're not really used to using it that way. And then also you're not used to doing operations when it's written in this form. That's one nice thing about fractions. It's so convenient to just operate on the fractions directly because you already have experience with multiplying fractions and that kind of stuff. So so we're gonna jump into that. So but these are the same, right? 50 milligrams per 1 milliliter is the same as writing it as 50 milligrams colon 1 milliliter, right? It's weird to do mathematical operations on the version that's on the right, okay? Right, okay. Let's see. Should I make this a little bigger? Let's see. I might make that slightly bigger. See if that works a little better. Okay, we'll figure it out. Okay, so next page, let's look. Okay, so we want to express dosages using the ratio format right here. So right now, we're not even looking at proportions or solving problems. We're just trying to figure out how would you write something like this. So You're basically looking at how much of the drug is existing in an amount of your whatever it is, the solution or the tablet or whatever. So you want to think of it, remember we talked before about that percent equation where you had the amount and the base, and you had to figure out which one was which? Well, it kind of makes sense that the denominator is going to be your base, like one tablet or 1 milliliter, whatever the amount is that's containing it, and then the amount of drug is kind of going to be in top there. So if we have an injectable solution that contains 100 milligrams in each 1.5 milliliter, then usually, and there's times when you can do this differently, but usually our default is going to be to put the 100 milligrams on top and the 1.5 milliliters on bottom. Right, we'll get some guidelines, especially in the next chapter, about specifically how to write these up. But when it comes to ratios and proportions, you actually have some options. Now, I don't want to confuse everyone by doing the problems a bunch of different ways, but what I will say is when it comes to ratios and proportions, there's more than one way to correctly set up these problems and solve them. The book is trying to keep you specifically tied down to one way of doing it, because I don't think they don't want you to get confused. They want you to just have one consistent way that you're doing it, and if you do it that way every time, then you're not going to get messed up as much, right? So we just want to be careful about that. So there's the writing of the solutions. I feel like that's pretty straightforward. What if you have a tablet that contains 0.4 milligrams of drug? Well, then it would be 0.4 milligrams over 1 tab. So you can see you're still just using whatever unit you're given. You're given a unit that is some weight of the drug generally in here, and then you're given some, whether it's a volume or it's a tab or whatever, you search for the problem, you get those 2 units. They have to give you they have to give you that information, and then you stick it in here, okay? So basically, when we have a ratio, like in this case 50 to 1, or in this case 100 to 2, well, if you think about it, what we're really doing is we're just preserving the ratio of that fraction. So when we simplify a fraction, what you're doing is you're keeping the ratio the same, but you're reducing it down to numbers that are a little bit easier to deal with. Now, you might sometimes need to do the opposite of reducing, right? Like we reduce numbers down as 50 to 1. Well, you might sometimes need to scale this up to 100 to 2. It's the same ratio. It's still 50 parts of, if this is milligrams to milliliters, then it's still 50 milligrams for each 1 milliliter and 100 milligrams for each 2 milliliters. Those end up being the same amount, the same strength of solution, right? But you're giving it, you could be giving it in different amounts. So just always think of that, like in math class and algebra class, we were always having you scale everything down, simplifying a fraction down. 12 eighths would become 3 halves, right? We were always having you scale it down. Well, sometimes you might want to scale up so that you can hit a certain target amount that you want. And we're going to look at that. So, if you've got in this case, you're starting off with 50 milligrams per a single tab. Well, that's the same as 100 milligrams to 2 tabs. Start paying attention to the units. Watch your units in these problems. See how the units are consistent for these 2 ratios? Right, they have milligrams on top, tab on bottom. Yes, there are some other combinations that will work if you set it up correctly, but there's also ones that won't work. So that's why I'm trying to stay consistent with the book. And I will say over the course of these 3 chapters, the book does a couple things that I think are overly complicated, right? They make it a little more complicated than it needs to be they're trying to simplify certain things, but they make it a little bit more complicated. But here is one nice way to just always know you're doing it the right way and consistent is for this specific type of problem, you keep the units in these same places because, if we had 50 milligrams over 1 tab over here, and then over here we had tabs on the top and milligrams on bottom, that doesn't work because how could that ratio be the same, right? It's not going to come out right. So you have to be consistent with those units. And that's why I say, again, writing the units will guide you through how to set the problems up. I see students try to do problems like this where they leave the units off and then they're like, well, I can't figure out where to write the numbers in the right place, right? Because you're not writing the units. The units are really your guide. Use them. Let them guide you through the problem that you're working on. Okay. Let's see. So when we have a proportion is basically an equation with a ratio on both sides. So it's like we have these fancy terms, ratio and proportion, but all it really means is you have something like this. So how do you check if your ratios are consistent? How do we know that 50 to 1 is really the same as 100 to 2? Well, the numbers that we're dealing with are these like round numbers. It's pretty straightforward. Like I think probably all of us understand that 50 to 1 is the same as 100 to 2, right? But what if you're dealing with numbers that aren't so clean? What if you're dealing with some numbers that have decimals in them? What if you're dealing with some fractions? What if you're dealing with weird numbers like 37 instead of 50, right? Nice round numbers like 50 and 100 people are pretty good with. When we start throwing in 37s and 46s and stuff, then people start getting kind of confused about stuff. So how can we verify that these ratios really are the same when we get into harder problems? And the answer is we do what's called cross-multiplying. Now, I tend to, in an algebra class, I usually try not to teach cross-multiplication because it's actually a shortcut that then sometimes people end up using in the wrong situations. But in this situation, I think it probably is your best bet to go through and multiply. So what you're doing, if you look at these arrows, the arrows are actually a little misleading where you're like, wait, why are there 4 arrows coming out from the equal sign? What they usually do is have, see if I can find a better image. Let me see if I can find a better one. Hold on one second. Okay, let me see if I can get a good image here. This one's not bad. I just think sometimes the arrows can be a little bit misleading when we use them. So let's see. Kind of this picture right here. Oops. This picture. So basically what you're doing is you're multiplying diagonally. Okay, so that you can see the yellow part, the AD. So you're multiplying the top left with the bottom right, and that ends up over here. So you multiply those. And then you're multiplying diagonally from the bottom right to the top left, and that ends up over here. Okay, so just you're not like we're used to multiplying with fractions. You're supposed to multiply across, but we're doing this weird one because we're going across an equal sign. Okay, so it's this thing called cross multiplication. You can only do it when you have a fraction equals a fraction. If you have extra stuff on the sides, it doesn't work anymore. So be careful. Cross multiplication only works in this exact scenario where we have a proportion, where we have a fraction equals a fraction. If it's any more complicated than that, cross multiplication doesn't work, and then people try to use it, and it just makes all these mistakes, right? All these mistakes occur. So, like, that's really what we're doing. Where are we? Oops, I lost my book here. Sorry, I got to switch everything around so I can show the book now. That's really what they mean when they have these arrows, which is kind of, you didn't used to see this style. It's a little misleading. What you're really doing is you're multiplying diagonally. So you do the 50 times the 2. So see how they have 50 times 2 right here? Because we're multiplying the 50 in the top left by the 2 in the bottom right. We're multiplying diagonally down to give us this. And then we're multiplying diagonally up. So the bottom left up to the top right, and we're getting 100 times 1. So you can see the two different answers, 50 times 2 from this, this diagonal, and then 100 times 1 from this diagonal. But both of those equals 100, right? So once you get the same thing on both sides, then you know the proportion is true. You know that your conversion worked properly. So you take some amount, you convert it to a new version. If this cross multiplication gets you the same answer on both sides, then you did it correctly. Okay. So the same thing here with a more complicated one. 500 milligrams over 2 milliliters. If you simplify that fraction, you get 250 milligrams over 1 milliliter. Again, these are round numbers that are pretty easy to do. I'm sure everyone can follow that. This is why we're starting with these easier ones. But if I multiply down and across, I get 500 times 1. If I multiply from the bottom and up, I get 250 times 2. Although they're kind of being, so here's what I'll say, they're being inconsistent about which side they put these on, but it doesn't really matter. As long as you're multiplying diagonal and it ends up on one side of the equal sign, then it doesn't really matter which one's on the left and which one's on the right, because they're being inconsistent between these problems. But what the key is that if 500 equals 500, then you're good to go, right? It all sort of works out. So that's our cross multiplying. It may have been years since you did cross multiplying. So let's determine if this is true right here, right? You can start to see now we're getting into numbers that are not quite so obvious, right? When we're dealing with 50s and 20s and hundreds, it's a lot easier to see what's going on. Here, oh, I don't know. Did I do this correctly? I think it is correct, but let's take a look. So let's go to over here, and I will take this. Actually, let's do this. And let's take out that and those two. I'm going to make a couple copies of this one. Okay, so we'll kind of just ignore that for a moment. Okay, so we wanted to look at, oops, I keep losing the textbook. I got to make this a little bigger. It's just, then it doesn't fit right. Okay. So put that up there. We'll get the book. So we're looking at this. We want to know, determine mathematically if this proportion is true. Okay, so 34 milligrams in 2 milliliters, is that the same as 51 milligrams in 3 milliliters? That's not as easy to see. So, in fact, let me just move this here so I can still keep looking at it. Oh, I'm getting an error. What is the problem? There we go. Okay, so let me find where this is located. Okay, so we've got 34 milligrams over 2 milliliters over 51 milligrams over 3 milliliters. Okay, so that's what it looks like, right? We've got 34 milligrams over 2 milliliters equals 51 milligrams over 3 milliliters. Is this right? That's what we're supposed to figure out. I believe it is, but we have to verify that. How do we know? Before we give someone a dose of medicine, we better be real sure we're giving them the right amount, right? So what I'm going to do is I'm going to multiply diagonally. So 34 times 3. Okay, so 34 times 3 is 102. So that gives me, so I'll write it out here. So we've got 34 times 34. Yeah, we'll do it this way. 34 times 3 equals. Okay, now I'm going to multiply the other way. So I did the top left to the bottom right. Now I'm going to do bottom left to the top right. So that's 2 times 51. So that gives me 51 times 2 Now, we still don't know, right? Some of you that can do multiplication in your head, you might already see. These are both going to come out to 102. So when we multiply this out, we get 102 equals 102. Oops. 102 equals 102. Give it 1 second to fix that error, that typo. There we go. 102 equals 102. We got the same number on both sides. Therefore, we know that's correct, right? So, we were, maybe we're given on the bottle that there's 34 milligrams in 2 milliliters, but we're supposed to give 51 milligrams, and we calculated that that should come out to 3 milliliters, but we want to make sure that that's correct. Well, this proportion says that that is correct. That is the right way to do it, okay? Let's see if I can find one where I think it's not going to work so that you can see what happens when it comes out to be not true. Looks like 4 should work. So number 4, 150 units to 2.3 milliliters. Is that equal to 130 units to 1.9 milliliters? Well, let's find out. Let's do the problem. Because if that's true, then that means that the ratios of units to milliliters should be the same on both sides of the equal sign. Let's see if that is in fact true. So let's try this problem again. But this time we'll make it 150 units to 2.3 milliliters, and then 130 units to 1.9 milliliters. Okay, so you can see it's the same as number 4 in the book, 150 units to 2.3 milliliters, 130 units to 1.9 milliliters. Okay, so now we're asked to figure out, is this proportion true? Is the ratio of this units to volume the same as this units to volume? Well, we're just going to use that cross multiplication. So start top left and multiply to bottom right. So when I do that, this is really going to be 150 times 1.9. And we want to know, is this going to equal? Now we do, right? It makes like an X because you're multiplying diagonals. So now we're trying to multiply the other way. 2.3 times 130. So 130 times 2.3. Now I don't know. Let's see what these come out to. Okay, so 100, and this is where you might get a calculator out. Oops, wrong button. 150 times 1.9 is 285. Okay, so 285 equals, and now what's 130 times 2.3? So 130 times 2.3 is 299. Okay, those numbers are not equal to each other. So see how in the first problem we did, the left side and the right side ended up equaling each other, so we know those ratios are the same. Here, the numbers did not come out to be the same, therefore these ratios are not right. So if we were given, on a bottle, it told us that there's 150 units in 2.3 milliliters, but we're expected to give 130 units to a patient, and we calculated that the amount we should give is 1.9 milliliters. We are wrong, right? This confirms that our conversion was incorrect. So really important not just to do a calculation, but to check a calculation, right? To make sure, always double check and try to find clues as to if your answer is correct or not. And in this case, we can see that, nope, this is wrong. I like whatever this was that we came up with over here, that is not the correct amount that we should be using. And then we can go back and fix it before, before we make a mistake that we will regret, right? Okay, so it's just you set up a proportion with your two ratios. So dosage calculations using ratio and proportion expressed as common fractions. That's what we want to be looking at. That's kind of the one I encourage you to use. You can be familiar with the other one as well, but the calculations usually are just going to go better if you have the fractions. So ratio and proportion are important in dosage calculations because they can be used when only one ratio is known or complete, and the second one is incomplete. So you have to have most of the information. Generally, if you look at our proportions we've been setting up, you have 4 pieces of information, right? You have 2 numerators, 2 denominators. You have 4 amounts. The ones we've been looking at, like this one right here, we had 4 things: 150 units, 130 units, and then we have these volume amounts, right, where we're looking at these volumes. So 4 pieces of information that you need, and you generally need to know 3 of them. If you don't know 2 of them, then you're in trouble, right? But generally you're going to have 3 of them because probably 2 of them are going to be given with the drug that you're trying to administer. It's going to be giving you the strength of the drug that you're dealing with. And then you're gonna probably know, you're gonna have the order that you're supposed to give them, right? Which says you're supposed to administer 130 units, right? So the bottle might give you these 2 pieces of information over here. And then well, I'm supposed to give 130 units to my patient. So the thing you have to figure out is this 4th piece, this 4th volume down here that you're trying to calculate in order to complete the calculation. So generally you're going to know 3 of the 4 pieces, and you just have to figure out which one is missing. And we're going to do that basically the same way we did this to verify, except you're just going to have a variable in there, but we're still going to do that cross multiplication where you're multiplying diagonally. You're still going to do that, okay? Okay, so let's take a look at how we would do that. Right, and then they're just saying here, we can see on the next page. Oh yeah, so let's set up this example and work through it. A solution strength of 8 milligrams per milliliter will be used to prepare a dosage of 10 milligrams. So that is, you've got like, some medicine, and it says this medicine is 8 milligrams per milliliter, but your patient doesn't require 8 milligrams. He or she requires 10 milligrams. So you have to figure out then, well, how much am I supposed to administer in order to make sure that they got the 10 milligrams that they need? So you have the known part, 8 milligrams to 1 milliliter. That's probably written on the bottle, right? You have your order that you're supposed to be administering 10 milligrams. The unknown that you have is the volume that you should be administering, right? So we set this up just like the problems you've been looking at, and notice how we're consistent with the units. Milligrams go on top, milliliters on bottom. Now you'll have problems where it's other units, but you want to stay consistent, where you're consistent about writing those units in the same place, and then you won't mess it up, okay? Now, they do mention here the ratios and proportion are written in the same sequence as of measurement units. So like on the vial, you're given it in terms of milligrams per milliliter. Well, then just go with that. That's like, why change it, right? Why complicate things? Right. So then what we do is we set this up. 8 milligrams to 1 milliliter equals 10 milligrams to some unknown value. And you can see that symbol again. What are we doing here? We're cross multiplying. So you can see we're multiplying the x times the 8, right? Top left to bottom right gives us our 8x piece. And then from bottom left to top right, we have 10 times 1. So that's where the 10 is coming from. So we're seeing 8x equals 10. Well, when you divide both sides by 8, you get 5/4. 5/4, if you put it in the calculator, right? 5 divided by 4, 1.25. So then you know that's where this answer came from of 1.25 milliliters. That's where that came from. And now you know, oh, okay, the amount I'm supposed to be given is 1.25 milliliters. That's the correct dosage. Now, if you check this, the way that, like if you fill in 1.25 down here for x and you do the cross multiplication check like we just did, you're going to get the same thing on both sides. It's going to come out and be equal. So then you know that you didn't make a mistake when you did that. Okay, so see how we're basically taking the same steps we just did a minute ago, and we just have a variable in it now. There's an unknown value in it, but we're really going to do it the same way. So so let's do this one. So let's work through example 3. A dosage of 200 milligrams must be prepared from a solution strength of 80 milligrams per milliliter. Okay, so let's go to our problem and we'll work through it. So I've got 80 milligrams. What was it per milliliter? 80 milligrams per milliliter. So that's to 1 milliliter. And we know that we want to administer a 200 milligram dose. So milligrams are on top, right? So we want to keep on the second fraction milligrams on top. So I'm going to go, okay, we want 200 milligrams. And then on bottom, we don't know how many milliliters. That's our x. And you can choose whatever variable you want, but we've got some x number of milliliters, right? So we've got these lined up correctly, and these values right here are, don't pay attention to those. That's from the old problem. Okay, so now we're just going to do the multiplication. So when I multiply top left diagonal to bottom right, I get 80 times x, right? So that's 80x equals, and then when I'm multiplying the other way, I get 200 times 1, so 200. So 80x equals 200. Now we're going to divide both sides by 80. Right, so I'll just say divide by 80. And when we do that, we're getting x equals 200 over 80, which we can throw in, you know, you could simplify that or just throw it in your calculator. 200 divided by 80 is 2.5. Oops, I moved the wrong one, sorry. So to us, that should be 2.5. And you go, well, wait, how do I know which unit it's 2.5 what? Is it 2.5 milligrams or is it 2.5 milliliters? Well, partly if your head's in the game and you're thinking your way through the problem, then hopefully you're recognizing you should be using milliliters. But also just go back to the problem. Look where your x is. What is the unit that follows your x? It's milliliters. So that must mean when we plug 2.5 in here for x, we get 2.5 milliliters. Okay? And then, yep, that's the right amount. So we got the right one. So that's really, that's really what there is to that calculation. So you'll do this a bunch of times, but the great news is it's basically the same problem every single time. They're going to give you different numbers and maybe say it in a different order and maybe even get more complicated over time. But it's basically that same calculation every time. You're going to set up the fraction that represents the dosage given in the problem. You're going to set it up with the equal sign, keeping the units in the right places. You're going to fill in the missing value, and then it's just cross multiplication and, a division and a couple multiplications and a division, and then you're good to go. So those problems do not get it's complicated. Now, if you want to learn how to do it with the ratios written out in the non-fraction way, go ahead, read that part of the book. If you really want to do it that way, I can't imagine why you would want to do it that way, because it's not as familiar since you're somewhat familiar with fractions. But by all means, if that works for you, do it that way. But there's a lot of different, it's a little more complicated to set it up this way, and they start getting into, memorizing things and stuff, so I wouldn't recommend it. Okay, let's see. I'm trying to remember if there's anything else. We don't want to do that. And you can just see, like, this looks confusing. We've got a ratio with a colon equals a ratio of a colon, and then we have to figure out everything. It looks way more confusing. So I don't recommend that. Right. So then what do we do when calculations when dosages are in different units of measure? Well, that's part of a lot of what the next chapter is about. And we kind of learned some of this in an earlier chapter, so you're already a little familiar with this. So if you're looking at this and going, well, I kind of already think I know what to do here, you might. You very likely might. We've already kind of been exposed to this problem already, but they're bringing it up because it's relevant, right? Just to make sure. So right. So you might be given an order to give 0.15 grams of a medication, but the dosage strength is expressed in terms of milligrams, 200 milligrams per milliliter. And then you're like, well, wait, I've got grams here and I've got milligrams over here. Well, what can I do? Well, the answer is you convert the one using those metric conversions that we dealt with. Like, I don't know, was it the first chapter we did where we did like the metric system and stuff? So we can't, you have to make sure that, like I was talking about, the units have to line up. If the units are not the same, then your cross multiplication isn't going to work right because your numbers are representing different things than what they're supposed to. So for instance, all you'd have to do in this case is take, we've got 200 milligrams to 1 milliliter. That's the dosage that's on the bottle, right? Except you're supposed to give 0.51 grams, and you don't know how many milliliters that should be. Well, look what they did. They just converted grams into milligrams using those metric conversions that we did early on, and then it's not a problem. So remember, what do you do with your if you've got something in terms of milligrams, we're going to move 3 decimal places, right? So if the zero's here in front, or the decimal's here in front of the 1, and you move 3 decimal places, you end up with 150 milligrams. And then look at that. Everything works, right? So you just fall back on your previous knowledge of the metric system in order to get your conversions right. And then it's just like the previous problem where you're going to do, or the previous problems, where you're going to do cross multiplication and you're going to get your answer. So you always want to watch for that, though, because that's easy to miss. When you're dealing with one thing in terms of milligrams and the other in terms of grams, you want to make sure you recognize, wait, these units are not the same. It's easy to miss that, and then all of a sudden bad things are going to happen. So pay close attention to those units and make sure that you're being consistent with those. Okay, I want to make sure we get to the next chapter because that's a big one. So let me get there. So, and you can see what's going to happen in the homework. You're going to be shown like a label. So you've got like a dosage and stuff here, right here, 250 milligrams and 5 milliliters. And then you have to figure out what's the proper dosage to give the person, and it, might be different. Okay, so, all right, let me take roll while we're at it here. So let's see. Thanks to everyone who put your name in chat there. If you don't have it in there yet, please throw it in there. Just makes it all a lot quicker. All right, we got this person. Carly, did you say you were in here somewhere, I think? Yeah, so Carly's here, or at least was. And then, all right, let's see. Do any of these look weird? Okay, that looks good. Okay, so let's move into the next set, which we need to look at, which is, oh, sorry, that's what I wanted there actually, which is this dimensional analysis. This is really the most important tool from these 3 chapters. The other ones, excuse me, the one we just looked at and the one from chapter 14 are almost like shortcuts for this method here. Like when the problem is really simple, it's like a shortcut for it. But you can use dimensional analysis to basically convert between anything. So this gets done a ton in chemistry. It gets done in physics as well. But like all the time in chemistry, you have something in terms of 1 unit, and you need to convert it to another unit. If you remember back from chemistry, there's lots of different ways of measuring the strength of something, right? Because you have different units. You might have it in moles or, milliliters, lots of different ways you can count things. But you want to make sure that you can convert between those ratios. So like here's an example. Lots of different ways we can express things. Well, we always want to match things up in the right kind of units to make sure that we're doing it correctly. And again, the key to doing this correctly is all about the units. If you are doing these kinds of problems without writing down units, then right now you're basically making it harder on yourself. I know it may seem like you're making it easier, but mistakes are costly. And I mean, obviously in the real world, when you're doing your career, mistakes are very costly. But even here on the homework, one mistake ends up taking a ton of time because you're like, wait a minute, what's wrong? You got to figure out what's wrong. You got to fix it. Rather than just going slow and making less mistakes, you'll actually finish sooner. So I know a lot of times people want to just skip. Oh, I don't want to have to write an M and an L. I don't want to have to write an M and a G. I'll just skip that step. But that fraction of a second you save, you're going to pay more than that back when you make a mistake and end up having to figure out where that mistake is. So, and then obviously even bigger consequences down the road later when mistakes get made when you're actually doing this kind of stuff. So there's the basic setup for in nursing or healthcare, they call it dimensional analysis. In science, they just call it unit conversion, just how you convert units to different things, okay? So they give you kind of a guide, which is slightly different than how you might do it in science, but they give you a starter, and in the book, they put it in pink so that you can kind of keep track of it. And that is, you basically want to ask yourself, what is the thing I'm supposed to end up with? Like, what is it I want in the end? And oftentimes, at least for the problems that we're doing, the thing you're going to end up with is milliliters. Okay, so you can see, I want to know some amount of milliliters. And then what we're going to do to the right of this equal sign, we're going to build our conversion to get everything converted. And then we're going to go from there. So the way this works is you start with whatever quantity you want. So if you're doing a problem and you go, okay, the unknown amount that I need to find is milliliters, then you start with milliliters. And then what you're going to do is think about it in terms of always getting things to cancel. So remember like how you would simplify a fraction? Let's say you had 4/6, right, as a fraction. What would you do? You would cancel a 2 in the numerator with a 2 in the denominator. That's what simplifying is you're canceling out common factors. Well, your guide through this problem is that you want to be canceling out units that you don't want to be there anymore. So we're guided by the fact that the unit we want is milliliters, and then we fill in the information that we have from the problem. So let's work through this one. The available dosage strength is 750 milligrams in 2.5 milliliters. Okay, so that's the dosage, that's the strength that we know. 750 milligrams in 250 milliliters. Okay, how many milliliters will be needed to prepare a 600 milligram dosage? So from that, we say, okay, they're asking me how many milliliters. So boom, right here, we can put that in the pink spot. We're looking for milliliters. So we go milliliters equals. Okay, that's you don't have to write that part, but it kind of helps you focus on what you're looking for, right? A lot of times in a question like this, people will ask me like, well, I'm not even sure what I'm looking for. So target that piece. We're looking for milliliters. Okay. So we write milliliters. So now what you're going to do is you're going to write this fraction over here in terms of making sure that the milliliters can't, like, they line up. So if we wanted milliliters here, then milliliters should go on top. Now I know that's kind of weird because we're used to writing things as 750 milligrams per 2.5 milliliters. But it's okay to flip that fraction upside down because those two amounts are in the same ratio, right? So we're going to write it where we have 2.5 milliliters on top and 750 milligrams on the bottom, okay? The way we know is, see how they're getting the pink parts to sort of line up? If you want this to be on the thing you're left with, it has to be on top over here. So that puts milligrams on the bottom, okay? Now, what we ultimately want, like we have milliliters here, but then next to it we have milliliters over milligrams. So what we need is for the milligrams to cancel away, and then what we will be left with is the milliliters. Right? We'll be left with the milliliters part. So we need to get rid of this milligrams that's right here. We need to get rid of that part. Well, how do you do that? You cancel it. So just like I talked about a minute ago where we would cancel a 2 from the top and bottom of a fraction in order to simplify it, you're going to cancel based on milligrams. So when we look at this, I say, well, I want my milligrams to cancel, so that means I need a milligram on top now. So that way, if I have a milligram on top and bottom, I can get them to cancel. See how the units are guiding us through? Each step that we've done so far, I looked at a unit that was written on my page, and that informed me where to write the next piece of information. Units is the whole key. Trying to do this without units is like, you might as well put a blindfold on and try to work through the problem. That's about how well it's going to work, right? So we've got milligrams on bottom, so now we put milligrams on top, and we've got our 600 there. So this is the ratio we're interested in, and we're going to multiply by 600 in order to do that. So these milligrams will cancel, and we're essentially left with a ratio at that point, but the unit we're left with is milliliters, okay? So when we go through and do this, you know, now you would get out your calculator at this point and go through and do the calculation. Let's see, where'd my calculator go? There it is. So let's start, and let's see, can I get them both on here? Or we can kind of see, I think I can. If we put that kind of there, oh great. Stop trying to do that. It's always great when Windows tries to like do things for you and then it just makes it worse. Okay, let's see. So we've got, just go through and do the calculations. Remember, things on top are multiplications, things on bottom are divisions. So I've got 2.5 divided by 750, right? That's this first piece. And then multiply by 600, so times 600, and I get my answer of 2, and we can see that's the answer, 2 milliliters. So see how we had a series of, we had what, a division and a multiplication we had to do, but it's real easy. If you're just doing this in your head, it's really easy to mix up what's the multiplication you should do and what's the division. But if you go through and set it up this way using this unit conversion, it's obvious. You go 2.5 divided by 750 times 600. You put everything in the right place, and then when we do that calculation, we got 2 milliliters, just like you're supposed to end up with. Okay? So it works. And then if you wanted to check it, you could check it like we did in the previous chapter. If you were kind of doubting what you did, you could go, oh, let me double check what how I want to do that. Okay, so let's do one without reading it we'll read it out of the book, but we won't follow their steps. We'll do it ourselves. So a dosage of 500 units is ordered to be added to an IV solution. The strength available is 10,000 units in 1.5 milliliters. Calculate how many milliliters will contain this dosage. So we have to figure out how many milliliters to administer to the patient. And we know that it's in the unit of, let's see, let me write this out. So we want the different thing now. We don't want this one. We want this. Let me cut and paste this here. Okay, so we want to end up with some number of units, and we know, what are we looking for? 1.5 milliliters to 10,000 units. Okay, so we know we want milliliters on 1,000 units. Okay, so we've got the milliliters that we want. We know that's what we want. So we match it with milliliters on top over here. And then we've got the 10,000 units. This is giving us the strength from, that we're given from the bottle, from the label that it's giving us. And then we're still missing a piece. We need to know a dosage of 50,000 units. We'll see how units is on the bottom. That means in this fraction, we want units to be on the top. So I'm going to put in there 50,000 units. 50,000 units. Let me move this. Let's see. Move that over so you can see it a little bit. Let me see. What if I do this? Okay, and then now we'll get out the calculator and go, okay, so I'm trying to make sure you can see everything here. Okay, so we'll go 1.5 divided by 10,000 times 50,000, and we get 7.5. So our answer then should be 7.5 milliliters. If we did that correctly. And let's see. Yep, 7.5 milliliters. And you can see, same setup that we did, right? They've got and they kind of messed around here with some, you can do that. You can simplify these fractions along the way. There's a bunch of different ways where you can actually work through the problem, and they're going to come out the same as long as you do accurate stuff. So if you're someone who likes to simplify a fraction before you put things in the calculator, do that. That's fine. That's legitimate. Here they kind of got rid of the decimal first. That's fine. That's helpful, especially if you're trying to do stuff by hand. Mixing decimals and fractions can be confusing. But we used a calculator, so in that case, it didn't really matter if we were dividing by decimals or not, because we had the calculator do it. So it just kind of depends on you, basically. Okay, let's see. And that's kind of like the previous chapter. Like, there's like one operation. You're just going to do that one operation again and again and again. There's only one more complicated problem in here, and it's basically the problem you just did, except there's like one more step you sometimes have to add. Let me see if I can find that problem somewhere. Where was it? Oh, here we go. Equations requiring metric conversions. So if, just like in the last chapter, we did these problems, and then on top of that, you have to do a metric conversion, well, you can just do it right as part of that conversion that we're doing, right? Metric conversion, the whole thing we're doing is converting dosages. Well, it makes sense we could just do the metric conversion at the same time. So if you look, what this looks like is there's just one extra fraction in here. And that's exactly what it is. You're always just lining things up so that your units will cancel. So see how we've got the milliliters lined up, and then we've got grams up here and grams down here to convert to milligrams, because if we want this in terms of milligrams instead of grams, right? So this problem says the IM dosage ordered is 275 milligrams. The drug available is labeled 0.5 grams per 2.5 milliliters. How many milliliters must be given? So notice that there's a discrepancy between the order that we have, which is 275 milligrams, versus the label on the drug says 0.5 grams. Again, we have to recognize, like, oh, grams and milligrams are not the same thing. I have to convert one to the other. So notice that the fraction they're multiplying by is literally a form of 1, because remember, we can always multiply by a form of 1 in a fraction. We do that a lot, where we turn a fraction into a form of 1, we can multiply it. Well, that's what this is, if you think about it, because 1 gram is equal to 1,000 milligrams. So if you put 1 gram over 1,000 milligrams, that's just a form of 1, because 1 gram is, oh, sorry, I'm doing distance, but 1 gram, the weight of 1 gram, if you have a scales, you put 1 gram on one side, you put 1,000 milligrams on the other side, they balance because they both come out to 1 gram, right? So that's where this is. That's just a metric conversion. You put the two, you're putting the thing on top is the thing you want to cancel. So see how we're trying to get rid of this 0.5 grams? So we put grams on top, making it 1 gram, because gram is that base unit for weights in the metric system. And then on top, we put the unit we want it to convert to, which is 1,000 milligrams. So we're trying to get from grams to milligrams. So you set it up in the order where the grams will cancel. If you do this backwards and you put milligrams on top and grams on bottom, then the blue grams wouldn't cancel because they would both be on bottom. So it's really important. If we're trying to cancel grams over here, we got to put grams on top over here. And the unit we want has to go on bottom, which is milligrams. And then I know, okay, well, since this fraction has to form 1, then 1 gram on top is equal to 1,000 milligrams on bottom. Those equal out. And then we can go forward with the problem. And then it's literally just like one step farther than the one that we did a moment ago, right? See how it's 2 full fractions and then a half fraction on the end? It's like one more step than the one we just did. If you're taking chemistry or physics or one of those, then you have these where you'll have a big string where it's like maybe 5 or 6 conversions that you do along the way. So at least in here we're keeping it short. It's like in this case, it's like 2 conversions that you're doing along the way. So it's actually simpler and shorter than what you'll do. Those of you who end up in like chemistry classes, you'll be doing much longer chains of these conversions in order to convert from one type of thing over to the other. And then you can see everything canceling. See how the grams cancel, then the milligrams cancel, and then when you put all these in here, so watch, when we do this, we go, can you see that yet? 2 divided by 0.5, and then divided by 1,000, and then times 275, and you can see you get your 1.1 that they got in the problem, right? So it's just a matter of once you get this set up, this is basically telling you how to feed it into your calculator, and then you feed it into your calculator and you get your amount, 1.1 milliliters, right? So it's not really any harder than the ones we just did. It's just you have this extra fraction, which is a metric conversion, right? Yeah, we're good on time. So let's see. What's the one I want to do? I'm sorry. Can you repeat that question?
Exam behavior. I don't see the actual screen that you're typing the numbers into.
Oh, right. So if you're in Zoom, you're not going to see them. If you jump over to the YouTube stream, you'll see all the stuff that I'm referencing.
Oh, gotcha. Okay.
And then that's also recorded. So if you miss some stuff and you want to go back and watch it, remember it's stored on the YouTube channel so that you can just go back and watch any of those, and you can go back and watch those. Yeah, so let's walk through this one, and then I think we'll probably want to switch over to the other chapter. I'll at least talk about it real quickly. So let's do this one. So this one is what we're looking at. The medication has a strength of 0.5 grams to 1.5 milliliters, and we are asked to we want to come up with an amount of milliliters. So the same way we've been doing it, we're going to have milliliters on the left, and then we're going to change this fraction a little bit. So this is going to equal, let's see, we're going to end up with milliliters in the end. But in the meantime, we have, what is it? It's 0.5 grams to 1.5 milliliters. Okay, so we know we want milliliters on top. Let me just move this then. So we've got, okay, so it's 1.5 milliliters, which I already just coincidentally happen to have there, but this is going to become 0.5 grams. And then over here, so we can see we have grams on the bottom, and we want grams to then be on top up here where I have units from the previous problem. So I'm going to convert that to be grams. And since gram is our basic unit of measurement for weight, we're just going to have 1 gram. And then I want it to be, let's see, how many milligrams do we want? We want that to be, so in 1 gram, there is 1,000 milligrams. Okay. So now our grams are going to cancel, but if we do this calculation like we have it now, well, now we've got this milligrams in there that we are going to be stuck with. We'll actually have milliliters per milligram, which is not what we want. We don't want a ratio. We want an actual amount. So we need to be left with milliliters. So now we need this milligrams to cancel. So then what we're going to do is recognize that in the problem we were told we want to prepare 750 milligrams. So our next fraction then, we're going to get this to be C dot fraction 750 milligrams over 1. Let's see if I can stretch this a little bit. Not really. You can see we've got this gram in the denominator canceling with this gram in the numerator. This milligrams in the denominator is now going to cancel with this milligrams in the numerator. So when we go through and do this calculation, we should end up with this, with the correct amount that we want. So this is telling us then that I should be taking 1.5 and dividing it by 0.5 to get 3, and then dividing that by 1,000, and then multiplying by 750. If it's in the top, you multiply. If it's in the bottom, you divide. So times 750, and we get 2.25, which should be our answer if we get this. And sure enough, you can see you do end up with 2.25, and then they have you rounding. So just be aware, because a number of examples do this, and it's the same for the homework. They're having you generally round to the 10th place because they're having you round to whatever gradation you have, the calibration you have on, you know, if it's a syringe or something like that. So you can see they got 2.25, which is the same amount that we got, but then they round it to 2.3. They round it to 2.3 milliliters there. Okay, so that's all that's going on with that. Oh, perfect. That was the end of the chapter there. So real quick, I can talk about the next chapter, which again is kind of a shortcut. You could just use what we were looking at to do it, but they take a very simplified special case and give you like kind of another formula to learn, but it's simplified for that specific problem that you're trying to look at. In other words, we've got what's called the formula method. I kind of just like using, I'm a big fan of you learn one formula, and if that formula works in 3 different situations, just learn the one formula, namely the one we just talked about, the unit conversion method. My recommendation would be know that way inside and out, because it will also work in a lot of these other scenarios for you. But then sure, if you want to learn these extra ways to do it, go for it. So you've got your formula method here. So we've got the basic formula, which says the initials most commonly used in the formula method are as follows. So we've got, let me move this over. D is the desired dosage, so that's whatever you've been ordered to give. That's what D is for desire. There's some desire to give a specific dosage, right? H is what you have, so that's the strength available. Q is the quantity, so the milliliter volume the dosage strength available is contained in, and then X is the unknown. The milliliter volume and desired dosage will be contained in. They say it is necessary to memorize this formula. Printing it several times will help you remember it. That's actually true. So you want to know this formula. The fastest way to memorize a formula, like it says there, just write it. Like write it 50 times. And people go, oh my gosh, 50 times. But if you think about that, you can probably write that thing in 5 seconds, right? So that means you could write it 12 times a minute, which means you could have it done, you could write it 50 times in a little over 3 minutes. If you say it each time that you write it and you're writing it out, you'll have it memorized. Okay, so because this like the unit conversion method, it's logical. It makes sense. You don't necessarily have to memorize anything there because it just makes sense, right? You can reason your way through it and go, well, the unit I'm trying to cancel, I have to cancel it with one in the other part of the fraction, and I have to line everything up so everything cancels right. It just kind of makes sense, right? Whereas here, because it's a formula, whenever you have a formula you're working with, if you generally have to memorize the formula because that's the point of a formula, is it gets you through there. Right. So what you do, basically what you're doing in this case, and it's similar to some of the problems we did in the previous one, which is why that method will work as well. But basically what you're doing is you're taking the ratio of the amount you have to the amount that you want, the desired amount, and you're going to get a ratio there, and then you're applying that ratio to the volume. So you're basically taking the ratio of your medicines and then applying that ratio to the volumes, and you'll end up with the same thing. I mean, really, this is really almost exactly like the very first chapter we did today with the cross multiplication, except they've already solved part of the problem for you, so you don't even have to do the cross multiplication. It's like they've even taken that out. But you could do this with the unit conversions if you wanted. So you can see, what do we have here? Yeah, I have a couple minutes to talk about it. So a dosage of 80 milligrams is ordered. The dosage strength available is 100 milligrams in 2 milliliters. Calculate the milliliters necessary to administer the dosage. So see, they've given us 100 milligrams is what we want. 100 milligrams is what we have. So that gives us a ratio. We can figure out a ratio of 80 milligrams to 100 milligrams. And depending on which way we're doing the problem, it's either going to be 80 to 100 or 100 to 80, whichever, in this case, they're doing it D over H. So the desired amount over 100. But what I'm saying is, from a mathematical standpoint, you could actually do this problem a couple different ways, but I don't want to confuse anybody by doing that. So I'll stick to what they have in the book. But I'm trying to get you to understand what it is. You should always understand a formula before you use it. You're less likely to do it. So what this fraction right here, this 80 to 100, that's giving us the ratio between the dosage that we need to the dosage we have. Once we simplify this, we apply that same ratio to the volume, the milliliters, and when we scale that volume down to the same ratio that we got for the medicines, then we should have the volume that we want, right? So they just fill it in. 80 over 100 times 2 equals the amount that we need. So 80 over 100 is 4/5. So 4/5 times 2 is going to give us 1.6. So you end up with 1.6 milliliters, right? So 80 divided by 100 times 2 gives you 1.6, and then you have the amount that you need. And they talk about in these, we've talked about this before, but just as a reminder, always do a common sense check when you're doing these and just ask yourself, does this make sense? Like, is that a reasonable amount, does it make sense that if there's 80 milligrams, or sorry, if there's 100 milligrams in 2 milliliters, does it make sense there'd be 80 milligrams in 1.6 milliliters? Yeah, that seems reasonable because for one thing, our volume got less, right? Well, we're administering less than 100 milligrams, so it makes sense that our dosage would be less than 2 milliliters. So that's, for starters, we go, okay, that's going the right direction. But then also there's scale, right? Does it make sense if we're giving a dosage of 80 milligrams and the strength given is based on 100 milligrams, well, then we would expect our volume to be a little less than 2 milliliters, right? Because our dosage is a little less than the described dosage. So if we make that one a little less, then 1.6 also makes sense as being a little bit less. Yeah, that seems very reasonable. If your dosage is going the wrong way, then obviously that's a mistake. But also if it goes the right way but it goes too far, usually you're going to be able to check that because a lot of times it's going to be off by a lot. And you're going to catch it and go, something doesn't feel right. It doesn't really seem right that this should be the dosage. A lot of times you'll catch it. Not 100% of the time, but a lot of times if you just stop and think about it for a minute, you'll catch it. So it's just a matter of take that formula that we got on the previous page, and then from the problem you just identify the D, the H, the Q, and the X, right? And it's really just a different way of doing those problems we started with. This is literally the cross multiplication problems. It's the same thing. Like, it's the same problems, right? It's sort of like they've solved the cross multiplication for you now, so you don't have a proportion. They've gotten everything on one side for you, or you're going to do this when you do this. But it's the same mathematics, right? If we were doing this in equation, all we'd say is, okay, divide the right side by this value. Like, it's the same thing. Like, when you learned this in pre-algebra, you just did it all at once. You didn't learn it as 3 separate chapters. You just learned it as 3 different types of problems in the same chapter, and you solve whichever thing it is that you're missing in the problem. Okay. And then you can have the metric conversions in there. But at this point, hopefully you're very comfortable with the metric conversions. So you just have to catch them in the problem. If they give one of them to you in terms of grams and one of them in terms of milligrams, then make your conversion and do the problem that way, right? Yeah, and it looks like that's it. So with that, let me just double check what I want to say. So you've got your new homework assignments are up. Those chapters are up. There's only one video this time, and you've actually seen it before. Probably do you some good to read or watch it again. But also, the problems that you're doing are very similar to the problems in the book for this section. So, like, there's not a lot of variation in the problem. The only real difference is the numbers are different, obviously, and they're using a little bit different units. One problem might use grams. Another problem might use milligrams, like micrograms for another problem. There's that conversion, but that's pretty basic since you know your metric conversions at this point. So, you can go in and do the new homework assignments now. The homework is up for those new chapters, and then you've got your discussion. And now that we're done with these old ones, I can go back and grade those now. I should probably get those graded tomorrow, hopefully. But you can start leaving your, 17th pass. So start getting ready to do the ones. You have a few days before you do this discussion down here. But make sure you're staying current on that homework. I do not advise you to wait till the homework's due to do it. I advise you to do it as soon as we talk about it. Try to get it done. Right? It's the same amount of work either way, but you've got it out of the way. The sooner you approach the homework, the more you're going to remember about our discussion from class, and the easier it's going to be for you. Okay? So use the book as your guide. If you have to, just use the ebook. If you don't have a physical copy, I know some of you decided to get the physical copy, which I think is very helpful. Some of you just have the ebook. Just do what I do, where you open the ebook off to the side, and then you can move it out of your way when you don't want it, move it in there when you need to look up a problem and remember how they did one. And then you can look in there and follow along with the book. Okay? So we will continue next week we'll have those 2 chapters we're doing next week. So I'll have that all ready for you. So try by the next time I see you, try to have all this homework done. And then, if there are questions, we can go over it. But I think since the problems are all pretty much the same for each chapter, I think people probably will do okay with it. But feel free to get help if you need it. Otherwise, we'll see you next time. So as always, I'm going to close down the YouTube stream, but I'm going to leave Zoom open. So anyone who has questions for me, stick around in Zoom, and I'm happy to help you with whatever. Right? Whatever you need in order to keep progressing through the class successfully. Stick around, ask me questions, and then once no one has any more questions, I'll close that Zoom meeting. But if you want to ask me anything or talk to me or anything like that, please hop into Zoom, and I'll look at that stuff with you. Okay? So, thanks, everybody.